Okay, so we're going to simplify expressions today. Lots of different kinds of expressions. So these things right here, you guys, are just a whole bunch of rules. You probably already know them and remember them. So when you're multiplying and the bases are the same, right here the base is an A, right here the base is an A, then you add those exponents. So this is an M and this is an N, and you add them together. So look right here, guys. X to the second times X to the third, bless you, it stays in X, and then you go 3 plus 2 is 5. The next one is when you divide, you subtract. So look right here. And I don't even think about it like that, you guys. I say, look, I have 9 on top, 2 on bottom. Where do I have more? On top. How many more do I have on top? 7. So R to the 7th is on the top. Okay, everybody watch these right here. A to the M raised to the N, you multiply those exponents, so it's M times N. Right here, Y to the third raised to the fourth, it's 3 times 4 is 12. Okay, if these are raised separately, see right here how it's A times B raised to the N. Here's how I tell you to think about it. This is an A to the first, and that's a B to the first. Then you do the rule up above. 1 times M is M, so the A is raised to the M. B is 1 times M is M, so the B is also raised to the M power. So look at this one, guys. The 2 is raised to the first. This is kind of a big one, so look right here. The 2 is raised to the first, and the C is also raised to the first. So the 2 is raised to the 1 times 4, which is 4. The C is raised to the 1 times 4, which is 4. And 2 to the 4th is 16. Okay? If you have a negative exponent and it's on the top of a fraction, you just bring it down and it becomes a positive. If it's on the bottom of a fraction, you bring it up and it becomes a positive. So that's like on the top of a fraction. So if you look at this right here, you say, okay, there's nothing wrong with this 3, but the x can't have a negative exponent. So the 3 is going to stay where it is. The x comes down, becomes a positive, and that's it. Who's following me? Fine. And like, I totally remember all this stuff. Okay, great. And then anything to the 0 power is a 1. So if you come right here, x to the 0, you just replace it with a 1. Okay? Okay, now we're going to use those, and I'm going to go slowly, okay? Okay, here we go with question A. I need you guys to talk to me, okay? I'm going to keep question you. I need you to participate and answer. Okay, everybody look right here. I'm multiplying. This multiplied by this. So just multiply the numbers together. 4 times 2 is 8. And then you've got an x to the, you guys, what do I do to the exponents when I'm multiplying? Tell me that. You add those. Good. So 4 plus 3 is 7. That's your answer, and you're done. So this is just a whole bunch of remembering the rules, really. Okay, look right here. Same thing. Now we just have a lot more things. Look, this times this. Watch how I do this, guys. A negative times a negative is a positive, so I know my sign's a positive. Now I do my numbers. 4 times 3 is 12. Look at the x's, you guys. You have 3 here. You have 2 there, and you have 1 there. So altogether, everybody tell me, what do we have? We have 3 is correct. Good. Look at the y's. You have 1 there, and you have 3 there. Everybody in the room tell me, I have a y to the what? 4th is correct. Good. And then you have a z, and the z is just raised to the first power. That's your answer, and you're done. Okay? Question C. Now, everybody stop right here. Right next to it, actually, let's see if I did that for part D. No, I did not. Okay, so for part C, what I want you to do is I want you to take a line right here, and I want you to, right next to it, put negative 10 in parentheses raised to the second power. Okay? Someone raise your hand and tell me the difference. Go ahead, honey. Thank you.
So with the one to the left, you're not going to multiply with the negative, but the one to the right you do.
Yeah, so this negative in this left one is not squared because there are no parentheses around it. So when you do this one, thank you, honey, so much. When you do this one, guys, the negative just sits right there. It's not squared. And then you go 10 times 10 is 100, okay? Look at the next one. This is, the whole thing is squared. So this means a negative 10 multiplied by a negative 10, which gives you a positive 100, okay? Listen what Weber State loves to do. This is what they say. Is this equal to this? why or why not. So if you get this problem, I would do exactly what we just did. Figure out what they're both equal to, and then I would say, on this problem here, that I've got a negative multiplied by 10 times 10. The negative is not squared. On this one, the negative is squared. It's a perfect answer, okay? You will see that very, very, very likely, okay? Okay, look at question D. We're going to go slowly. We're going to stay together. Look, everybody put a 1 here and a 1 there on those exponents. This is called the power to a power rule. I want everybody to answer me. What do I do to those exponents again? You multiply. Okay, so everybody put a 2, and then you have 1 times 3 is 3. Then you have an x to the 1 times 3 is 3, and then you have a y to the 2 times 3 is 6. So that's the second rule we've used now. When you multiply power to a power, okay, let me say it again. When you have power to a power, you multiply. Is that answer acceptable? What do you think? It's not. What can we do? 2 to the third is a what, everybody? 8. Yep. So this is 8, x to the third, y to the sixth. Highlight your answer, and you got it. Okay? I do think this will be all over your midterm. Okay? Okay, now we're going to divide. Dividing's easy. You guys, everybody in the room, tell me a number that goes into both 12 and 15. 3. Okay, so look what you do. 3 goes into 12 4 times. 3 goes into 15 5 times. So on the top you have a 4, on the bottom you have a 5. Now everybody stop and look at the D's. You have 4 D's on top and 4 D's on bottom. They're exactly the same. So those just cancel out and they're gone. Look at the F's. 3 on top and 1 on bottom. Everybody in the room, tell me, where do you have more F's? On the top. How many more F's do you have on the top than on the bottom? 2. So it's just going to be 2 F's left over on the top. Look at the G's. 5 on top, 2 on bottom. Where do you have more? On the top. Everybody tell me how many more? 3 more. That's your answer. Literally, that's all you do. Who says this is easy so far? Okay, good. Okay, question F. Power to a power. Everybody stop for a second. Don't go ahead of me. Power to a power, what do? Just tell me one word. What do you do the exponents? Come on, guys. You multiply. Thank you. So this is going to be a 5 to the 1 times 2 is 2. Why 1 times 2? Because the 5 is to the first, because there's nothing there. Then look at the x's. 2 times 3 is 6. Look at the y. 1 times 2 is 2. Then 5 to the second is 25. So your answer is 25, x to the sixth, over y to the second. Done. Okay? All right, question G. Okay, everybody freeze right here. Please don't go ahead of me, okay? It's just so bad for you to do that because you're going to get confused. What do you notice the second you look at it? Tell me. Negative exponents, right? So if you have a negative exponent and it's on the top, look what you do. You just take it and you pull it down. So the 5 squared comes down. The x to the negative third comes down. Everybody tell me what y to the 0 power is. That's a 1. So on the top you have a 1. On the bottom you have 5 squared, which is 25. X to the third. Highlight your answer and you're done. So just deal with it one variable at a time. Okay, look at H. People do this problem and they say, my answer is 1. Is the answer 1? It's not 1. They see the 0 power and they're like, oh, I know that's a 1. Look right here. This thing right here is equal to what? Tell me that. That's your 1. So you have 3a multiplied by 1, which gives you 3a. That's your answer. So don't go too quickly to the 1. Figure out what the 1 is and then make sure what it's equal to. Okay? Okay, here we go. Everybody stop. Here's where the rules start getting a little bit confused. You tell me. I want all of you to talk to me. If I'm multiplying things together, what do I do to the exponents? Everybody tell me. You add them. Okay? So watch. A negative times a positive is a negative. 4 times 3 is 12. I have an a to the first and an a to the first. That gives me an a to the what, everybody? To the second. And then the b's, you have a positive 4 and a negative 3. That gives me a what? A 1. Yeah, 4 subtract 3 is 1. That's it. So it's so easy as long as you remember the rule, right? Okay. Here's J. Everybody just freeze and look for a second. Don't write for a minute. The second you look at, what do you notice? The negative, right? So I'm going to bring it up, and my answer is 3x to the second on the top. Is that right? It's wrong. That's wrong. What's wrong with that? I marked you absent, by the way, because I've been over here since you got in. So will you make sure you come up and say, Waller, mark me late? I do it all the time. Okay, go ahead, honey. What's wrong?
The 3 stays on the bottom.
Why?
Because the exponent is on the 3.
Yeah, the 3 doesn't have a negative exponent. What's the exponent of the 3, everybody? It's a 1. So there's absolutely nothing wrong with the 3. It's the x that's the problem. So the x to the negative second comes up, and you have an x to the second over 3, and that is your answer. Okay, who says, I feel good so far? Raise your hand. Let me see. Okay, great. Okay, let's look at K. Everybody stop. Look what people do. Watch. B to the negative fourth, B to the first. That leaves me a b to the negative third on the top. Is that what you do? No. If you have negative exponents, okay, crystal clear, no question, the first thing you have to do is make them positive. Okay, so look what I'm going to do. I'm going to extend that line. This a to the negative second comes up and becomes an a to the positive second. The b to the negative fourth comes down and becomes a b to the positive fourth. So now all my exponents are positive, so now I can actually deal with things, okay? Look at the 12 and the 4. 4 goes into 12 3 times, 4 goes into 4 1 time. So let's see what we've got now. We've got a 3 on the top. Now, here's where you have to remember these rules, guys. Look, you have an a to the second times an a to the third. Do I add and get a 5? Or do I multiply and get a 6? Add or multiply? Tell me. Add is correct. So that is a 5. 2 plus 3 is 5. Look at your b's. I have a b to the first and a b to the fourth. Everybody in the room, that's a b to the what? Fifth. Yeah. Is there anything else I can do to that? No. I can't simplify it any further. That's my answer. Okay? Okay, here we go. Watch me. Will you watch? Just look up. Watch. Negative 4 comes up and becomes a 4. M to the negative first comes up and becomes a first. Right or wrong? That's wrong. Very common mistake. What's wrong with that? The 4, that negative 4 on the bottom, guys, look, it does not have a negative exponent. Who cares if it has a negative sign? It's the exponent I care about. Guys, look, that negative 4 is to the first, so he's not going anywhere. The only thing I have to move is this guy right here. So now take your pencils and bring that m to the negative first up, and it becomes an m to the positive first. What about the negative in front of the 4? Who cares? The number's just a negative. So you just go 4 goes into 8 2 times, 4 goes into 4 1 time. You know what I'm going to do? I would never ever leave that negative on the bottom. I'm just going to push it up to the top. So that's a negative 2. Okay? On the top, an m to the third times an m to the fourth, or first, is an m to the fourth. You guys look at your ends. I'm kind of doing 2 steps in one here. Look at the ends. You've got 2 ends over 3 ends. Where do you have more ends, everybody? On the top or the bottom? How many more? 1 more. Who says this is so easy? Raise your hand. Okay, good. Okay. It's pretty long. Okay, do I add the exponents or do I multiply the exponents? Everybody talk to me. Multiply. Okay, everybody stop. There's something else I noticed. There's 2 more things that immediately kind of pop out to me. What are they? You have a negative exponent. What's the other thing? You have a 0, which is a 1. So look, everybody listen to this, okay? Y to the 0 is a 1. If I'm multiplying the 1 by 3x squared, does that change the 3x squared? No. So you can literally just say that's gone. Because 1 times 3x squared is 3x squared, okay? Everybody put a 1 right here. And we're going to follow the power to a power rule. So look at your 3. It's raised to the 1 and then to the negative 2. Remind me again what I do to the 1 and negative 2. You multiply. Yep, 1 times negative 2 is negative 2. Look at the x. 2 times negative 2 is negative 4. Okay, now those are both negative exponents that are on the top of a fraction. Okay, bring them down to the bottom. So now I have a 3 to the positive second, an x to the positive 4. Someone in the room tell me what I have on top of that fraction. I have a 1. Good. So my answer is 1 over 3 squared is 9, x to the 4th. That's my answer, and I'm done. I do think that this will be commonly seen, all this stuff on the midterm. And the midterm's coming up, you guys. Okay, take a look at it. More complicated. Stop for 2 seconds. Look right here. Do you see how all this stuff is raised to the 3rd? And all this stuff right here is only raised to the 1st? So that's what I have to do first. Order of operations tells you to do exponents before you multiply. So see that 2a to the second b? I'm just going to write it down. I'm going to forget about it for a second. And this is the guy that I'm going to deal with. Okay? Look what a lot of people do. They'll say that's a 3. Go ahead and write that down. 3. And then this is an a to the 1 times 3 is 3. And then a b to the 2 times 3 is a 6. Now, you've got to put parentheses around it to show that they're multiplied, but there's something wrong with that. Can someone tell me what's wrong? Go ahead. The 3 is also raised. Guys, stop for 2 seconds. Look right here. A lot of what I do is I help you to see things right, because I feel like if you can see it right, then you can do it right. So look right here. Inside of the first parenthesis, we have 3 things. Look, a 3, an A, and a B. They are 3 separate things. They each separately have to be raised to that 3rd power. Who says I understand? Raise your hand. Let me see. Great. So the 3 is really to the 1 times 3, which is 3. Right? 3 to the 3rd is 27. So everybody write 27, A to the 3rd, B to the 6th, times 2, A to the 2nd, B. Everybody in the room, I want to make sure you know the rules. Now I'm multiplying things. Tell me what I do to the exponents, everybody. Add them. Okay, so 27 times 2 is 54. Look at the A's. 3 and 2 add to get a 5. On your B's, 6 and 1 add to get 7, and I'm done. Just a lot of rules. That's what this is. Okay, look. What do I do first? Do I start moving the negatives? What do I do? Power to a power, so I multiply those exponents. Look, guys. 1 thing, 2 things, 3 things, all raised to the 2nd. This guy has a 1. So it's a 2 to the 1 times 2 is 2. C to the negative 1 times 2 is negative 2. D to the 4 times 2 is 8. Let's do the bottom. Same thing. I have 2 things. This guy's raised to the 1st. They're both cubed. So 4 to the 1 times 3 is 3. C to the negative 2 times 3 is negative 6. Now let's move our negatives. So see this c to the negative 6? Let's pull it up, and it's a c to the positive 6th. The c to the negative 2nd on the top comes down and becomes a c to the positive 2nd. So on the top, 2 to the 2nd is a 4. On the bottom, 4 to the 3rd is 64. And then I have a d to the 8th on the top. Then look at your c's. 6 on top, 2 on bottom. That leaves me 4 on the bottom. Am I done? I'm not done, because 4 goes into 64. I know it does. Right? 32 times. So is the 32 on the top, or is the 32 on the bottom? Tell me that. Look, 4 goes into 4 once. 4 goes into 64, not 32 times. 16, thank you. 16 times. So on top you have a d to the 8th and a c to the 4th. On the bottom you have a 16. There's my answer. Why is the 16 on the bottom? Because the big number was on the bottom. So you can have leftovers down there. Okay? All right. Big, ugly problem. It's going to be fine. Okay. So many different ways to do this. Look what I'm going to do. So many different acceptable ways. What I'm going to do is I'm going to take that right there and simplify it. Then I'm going to deal with the -3 in a second. Okay? So let's reduce it. 3 goes into 27 and 16. 3 goes into 27 9 times. Now 3 doesn't go into 16. Silly. What goes into 27 and 16, everybody? 27 is 3 and 9 and 27, and none of those go in. Okay, this is going to be really, really ugly. So I'm changing this to a 3 right here. Okay, I'm changing the problem. Otherwise, it's going to be so ugly. Okay, now it will reduce. So 3 goes into 3 once. 3 goes into 27 9 times. Okay, now, so let's rewrite it down here. So down here I have a 9. Let's just write it the way you see it. X to the second, y to the -8, z to the -1st. Just write it the way it is. But don't close that parenthesis yet, because now I've got to move some things. Don't forget that you've got a -3 sitting out there as well. Okay, so all I've done is reduce. This x to the -5th comes up and becomes an x to the +5th. You can't cancel the x, y's, and z's until they're positive. Please don't cancel until they're positive. Y to the -8 comes down and becomes a positive. Z to the -1st comes down and becomes a positive. So now I have a 9 on the top. Also on the top I have an x to the 7th. On the bottom I have a y to the, can you tell me what that exponent is, everybody? What are my y's on the bottom right now? It is 10. Yeah, 8 plus 2 is 10. And then the z's are 4 and 1 for a total of 5. That whole thing is raised to the -3rd. Okay, so all I've done is simplify the inside. Who says gotcha? Doesn't that inside look so much cleaner than it did to begin with, right? Now we have to raise everything to the -3rd. Look what I have to do. Just look for 2 seconds. Here's 1. Here's 2. Here's 3. And here's 4. So I have to raise 4 things to the -3rd. Okay, so this 9 is raised to the 1st. So it's going to be 9 to the 1 times -3 is -3. X to the 7 times -3 is -21. Over y to the 10 times -3 is -30. The z to the 5 times -3 is -15. Super ugly. Why is it so ugly? Everything's negative. Is that a big deal? Nah, just flip-flop it. So the y to the 30th comes up, the z to the 15th comes up, the 9 to the 3rd comes down, the x to the -21st comes down, 9 to the 3rd is 729. So your final answer is y to the 3rd, z to the 15th, over 729, x to the 21st. There's my answer. Who says gotcha? Raise your hand. Okay, good. Okay, question 2. This is what they ask a ton. What's the difference? So here's what I want you to do on the midterm when you get asked this. I know they're going to ask you. They always do. So everybody go 5x in parentheses, raise it to the 0 power. And then I want you to draw a line. And then I want you to put 5x to the 0. I'm telling you, if you do this, you're going to get this right. Right here, the entire thing is raised to the 0. That's a 1. Right here, the only thing raised to the 0 is the x. So this is 5 times 1 which is 5. Okay, so what's the difference? Okay, so look what we're going to say. In parenthesis, 5x to the 0. Okay, everybody write this with me, please. Both the 5, I shouldn't do a capital right there. Both the 5 and the x are raised to the 0. It equals 1. Then I would say in 5x to the 0, comma, only the x is raised to the 0. This is 5 times 1, which is equal to 5. Perfect. They'll love that. Who says gotcha? Let's see. Okay, good. Explain why these two things are not equal. Okay, well, let's do it. Every time you're asked to decide if they're equal or explain why they're not equal to each other, let's just write it out. It's the best thing for you to do for yourself. Okay, so right here, guys, look. The 2 is to the first, power to a power, 1 times negative 1 is negative 1. The x, 3 times negative 1 is negative 3, and I'm going to say is not equal to 2 over x to the negative third, guys. That's 2 over x to the third. So I just pulled that the negative exponent down. And on this one, both of those have to come down. So the 2 comes down, the x to the third comes down, and that is not equal to that. That is perfect to do it just like that, okay? Now, they didn't really ask us to show you. They want you to show, okay? But now we're going to talk about it, okay? So we're going to the same idea. So we're going to say in parenthesis 2x to the third to the negative first, both the 2 and the x to the third are raised, what's it? Oh, is there a typo? To the negative first power.
So this says vertical, and this says vertical, and this says horizontal, vertical. So it's horizontal,
This should say
right?
horizontal.
Okay.
Yes, thank you. And then I would say in 2x to the negative third. Well, I don't even think I like that. Okay, I think I would say this. I would say this makes the 2 have a negative exponent comma, which moves it to the bottom. I think that's what I'd say. Okay? All right, who says I'm good? Let me see. Good. Okay, so, oh look. So I was actually looking at something else when I thought it was difficult. It's actually, which lesson is it? Yeah, it's this one. It's lesson 12 that I think is tough. I think this one that we're doing right here is going fine. Who says me too? I think it's fine. Okay, great. Okay, is that equal to 8 to the 6th? Okay, well, let's see. Everybody go 4 to the 2nd. And then go 2 to the 3rd. And see if that's equal to 8 to the 6th. So 4 to the 2nd is 16. 2 to the 3rd is an 8. And then 8 to the 6th power is 262,144. So I'm going 16 times 8, 128. So is 128 equal to 262,144? No. So I'm going to go back up and make that a not equal to. Okay? So is it correct? No. Can anybody understand how they even possibly got 8 to the 6th? Do you see how they did that? They multiplied the exponents, but they also multiplied the bases together. Everybody look right here. If you have x to the 2nd multiplied by y to the 3rd, could you ever make that z to the 6th? Something completely different. No, you can't even do anything to x to the 2nd, y to the 3rd. They're different, okay? So I'm going to say in 4 to the 2nd times 2 to the 3rd, comma, the bases are 4 and 2. You cannot change the base to a 9 or to an 8. You can't multiply those bases. Guys, that'd be like this. Look, x to the 2nd times y to the 3rd is z to the 6th. Something totally different, and they're not even the same to begin with. Who says I totally get that? Raise your hand. Let me see. Great. Okay, question 5. If the rational expression this represents the area of a rectangle, and this represents the length of the rectangle, what's the width? Okay, so everybody say area equals. If we're talking about a rectangle, someone tell me the formula for the area of a rectangle. Do you remember? It is length times width. Good. So the first one is the area. So everybody go 20x to the 3rd, y to the 2nd, over 6z to the 3rd times a. That's your area, is equal to the length, which they gave us, 5x to the 2nd, y to the 2nd, over 2z, multiplied by something, and I'm just going to put a w down at the end, at the bottom. So what do I have to multiply this 5x to the 2nd, y to the 2nd over 2z to get the other guy? Well, it's so easy, guys. Look, what do I multiply by 5 to get 20? That would be a 4. If I have 2 x's and I need 3, I need 1 more. I have 2 y's and I need 2 y's, so I'm totally good with y's. Look at the z's. What do I multiply by 2 to get 6? That would be a 3. I have 1 z and I need 3 z's, so I need how many more down there, everybody? 2 more, thank you. And then you also need an a. That's it. If I were you, I would just highlight it. And I'd say, there it is. Okay? Okay. Who says, I understand that lesson, I'm totally good. Okay. So